So it's a very long title. Um, Discrete probability distribution is what we're going to be focused on, and we're looking at the expected value using this formula here. So we'll talk about a game. There's a game where we have a spinner, and we have 10 even slots on a circle, which these aren't quite even, but essentially you take the spinner and you spin it around, and it lands somewhere. And if you land on an odd number, okay, which we'll quickly highlight, our odd values, so 1, 3, 5, 7, and 9, you multiply that value by 2 and move forward that many spaces. Where if you land on an even number, you actually go backwards that amount times half, or divided by 2, however you want to think of it. And we want to know what the expected probability is, I think, of one single rule. Yeah, so an expected probability. So they usually refer to it as E at x. And essentially this formula is the value of the first times the probability of that event happening, plus the value of the second outcome times the probability of that event happening all the way to the last, oops, the P's not brackets there, the probability of the last event happening. So what does that all mean? That was really ugly. Well, we'll go through these one at a time. The very first one, if we were to spin a 1, okay, that is an odd number. So essentially our value is actually 2 in that case, right? Because we take that value, that odd number, and we multiply it by 2. So our expected value of the very first one will be a value of 2. But we have to multiply that by the probability of spinning a 1. And what would the probability of spinning a 1 be?
1 out of 10.
Yeah, that's right. Because everything's the same, the probability of everything here is going to be 1 out of 10. So we're just kind of go through the list here and add all the values together. So probability of that event is 1 out of 10. Okay. The second event is we get an even number. And that even number is 2, but we have to multiply it by a half. So we would multiply 2 by a half, but the only other thing is we're going backwards. So what we'll do is we'll keep everything forward as a positive value and everything backwards as a negative value. So think of it like multiplying by negative a half, you could say. So we take our 2 times negative a half, and our value here is actually negative 1 times the probability of that event, which is still a 10th. So all of our probabilities are the same. It's our values that are going to be different every time. So we'll try to do this all mentally as we go through the next couple. So the next number would be what? 3. And how far would we move forward if we get a 3?
6.
That's right. 6 times a 10th. What's the value of getting a 4?
2.
Just
And
2?
-2.
Yeah, negative 2 times a 10th. So really this is just a practice now of going through all the values. So that was, and we'll keep these, that's a 1, that's a 2, this is a 3, this is a 4. We should be able to fit 5 here, and we'll continue. If we roll a 5 or spin a 5, what's going to happen?
Move for a 10.
Yep. Multiplied by a 10th. Okay. And we just kind of go through this practice. 6, 7, 8, 9, and 10. So we'll try to do this really quick now. Ready? Do we move forward or backwards on a 6?
Backwards.
How much?
3.
That's right. Negative 3. We'll keep the probability the same. For 7, forward or backwards?
Forward.
How many?
14.
Yeah. 8?
Backwards 4.
Yeah.
Forward 18.
Yeah.
And backwards 5.
And backwards 5. What was that? Blue, right? Backwards 5. And the probability of all of these is still times a 10, right? So there's a lot of fractions. We might want to take a calculator out here to go through this. I'm going to quickly try to put all these fractions together. So the expected outcome is going to be, the first one will be 2 over 10. So I'll get you to add, actually, I think we can do this all really quickly. 2 over 10 minus 1 over 10. That's for 1 and 2. We multiply negative 1 times 10. Does that make sense? Okay. 6 times a 10th will be plus 6 over 10. The next value is minus 2 over 10 plus 10 over 10, which is 1, minus 3 over 10 plus 14 over 10 minus 4 over 10 plus 18 over 10 and minus 5 over 10. So we know our answer is going to be over 10. We just got to figure out what all those values are when we put them together. Yeah, you got to calculate them. 2 minus plus 6 minus 2. See what you get.
I'm at 35.
That's what I got too. So 35. Which, how do we translate to that, to an actual value in terms of moving? What would that be? How many spaces is our expected move each time we spin? Do we move 35 out of 10 spaces? What does that mean? Let's convert it. What is that as a decimal?
3.5.
That's right. So what does that mean? Our expected value of each spin is going to be what?
Moving forward 3.5.
Moving forward 3.5, exactly. So we expect to move forward 3.5 spaces, which we know we can't technically do. You either move forward 3 or 4, but due to all of the backtracking, that's what our expected value is.